Welcome to my channel AI Basics with AK. Here we are with another new episode on object oriented programming. Why waste time? Let's jump directly into our episode. Episode 14, Object Oriented Programming. In this episode, we will explore on OOPS definition. OOPS is nothing but object oriented programming. And why we need OOPS? Oops, right? but it's a very beautiful concept. And what is the structure of OOPS? And its key principles? And how do we implement it in Python, or what is the syntax in Python? So let's explore the formal definition of OOPS. So what does the formal definition says is that it's a design philosophy or a design methodology that organizes software around objects rather than functions and logic. What does that mean? It means that it's a design philosophy that stands out for its own benefit. Why? Rather than creating functions and logics that we have explored in our previous episode, code organization happens around objects. What is objects? Let's explore this below diagram. Now assume that this is a class. It's more about class and objects. That's what it is. Assume that you have a fruit, and say for example we have to write separate functions and logics for apple, banana and mango. This becomes more complicated, right? Because we have to write duplicate functions for all three fruits. Say for example we create one class fruit that has with its own defined properties like taste, price, shape, etc. Then what happens is that the class or design of a fruit remains the same, and we can create the objects of fruits like apple, banana, mango as an object of a fruit. So in this way it is more organized, as we have seen it here, around objects. Why we need to complicate in this manner? What is the beauty? Why it makes stands out? We will explore in our further slides. As to appreciate this design philosophy, let's also explore this below car piece. So car has its own properties. Say for example engine name, engine, or say for example fuel tank and mileage, etc. And its separate car companies, maybe say for example Volvo, Audi, Tata, Honda, etc., like Toyota, remains objects of this specific class. Beautiful, right? Now let's explore why we need OOPS. First of all, it's very easy to understand, because if we have separate functions and logics for apple, banana and a mango, it would be very tough for people who are actually skimming through the logic. They will be very pretty confused. When it is more organized, it becomes much more easier to understand. In this way, it is easier to debug if there is any problems in the code. Hi friends. There is almost an 1 month delay in recording the previous section and this consecutive section. Sorry for this extreme delay for uploading the video, because I have been stuck up with some personal matters. Let's continue from where we left. So the next point of why OOPS is reuse of the code. How we can reuse the code? It's very simple. We have a class and we have an object. We are not creating separate functions or logics for separate fruits like apple, mango and banana. We are directly creating an object of this class which helps in reusing the code. Also, there is something called inheritance, where we can create subclasses to it. Say for example, there is a fruit class, we can create two more classes. Say for example, fruit grows on trees, maybe fruit grows on plants, and it can have a separate characteristics. Maybe this can have some basic characteristics, this can have something called enhanced characteristics that are there. So in this way we can also reuse the code by extending the properties of a base class, and this can be called as a child class. This is also called as a reuse of the code. And third thing is keeping it organized. We have seen it out, which looks very organized. There is something, it follows some hierarchical structure from classes to subclasses, and also there is an inheritance of these properties, and also there are objects that are created from these classes. Now, how we are protecting the data? We can protect the data by masking the functions inside it, and we use only say for example, if some of you have used this microservices of Amazon, we don't know the logic behind the microservice. We only know how to use that microservice. This is similar way how we can use the class functions as well. We don't know what logic it is, but what arguments we need to pass to that class or function is what we will this is the use case of this OOPS programming. And finally, of course, it is flexible, that we have explored in this example as well, where we can extend it, where we can create enhanced properties of the existing class and etc. So that's why it becomes so flexible. And of course, it's fun and cool because we can experiment it out, we can create our own logical structure. And of course, this becomes much more important when we actually explore modelings, where we can create classes to our own thought process. Especially this I have seen it out in neural networks. Okay, now let's explore the next section, the OOP structure, which already we have seen it out. There is something called a class here, if you can see it out here, and there are some basic attributes: color, brand and model. And then there are something called methods. You can call this as some functions inside this color, maybe repaint. Now I have created here objects. There are two objects. This is my car, maybe this is Helen's car, and the object is here, the color is red, Dodge, and model is Charger, and the Helen's car is color is blue, brand is Nissan and Altima. In this way we are able to create more objects with the same class attributes and methods. Also, which we have discussed here, we can create a parent class dog, and we can also create some child classes, which is a herding dog and a tracking dog. Earlier there might be a base method called bark, where it inherits that base method, and and then there is something called a new function which is herd. Here it inherits a bark which is inherited from the parent, and also it creates one more function called track, and then it creates its own objects of the herding dog, not the parent dog. It's a herding dog objects, which is Fluffy, Maisel, and this is an object of tracking dog, which is Duke, and this is an object of the parent dog itself, which is not part of a herding dog and a tracking dog, which is Rufus. That's how we can create own objects based on its classes to which it belongs, and also we can create more child classes from the parent class, which inherits the properties from the parent classes. Make sense? Now let's understand the 4 foundation principles of OOPS. The first one is inheritance, which we have seen it out here, which inherits data and behavior from the parent classes. Encapsulation, which we have seen it out, it protects the data. It contains information in an object, exposing only the selected information. You can think this is synonymous to your microservices. Similarly, it's an abstraction. It only exposes the high level public methods for accessing an object. And polymorphism, where many methods can do the same task, which we have seen it out in the earlier bark one. So this becomes the four important pillars of our OOPS. If you need more details, you can explore this reference which I have used while preparing these slides. And how we can create a simple OOPS class is in this way, where I am creating some basic properties, the name, breed, and an age, and I am creating three methods which are nothing but functions which I have told you, which is bark, sit, and display. What does this bark does? It says that this particular bark, there is nothing out, it's just a print statement. Particular dog is barking, particular dog is now sitting, and particular it displays the information, display info, its name, breed, and age. Here, how do I create an object? It's very simple. I'm creating a object called my dog. This is an object of class dog, which has been defined here, and these are my properties. Okay, that is Buddy, name Buddy, golden retriever, which is its breed, and 3 is its age. I have defined my dog here, which is my object, and I can call sorry, this annotations also is moving down sides, just please forgive me. Now how I can call it here, my dog dot display info. Now this display info is actually displaying the dog information. My dog dot bark, my dog dot sit. Say for example, if I create one more function, say for example my wife's dog, I can use the same function, same wife dog dot bark. It says that, okay, say for example it's maybe the wife's dog name is say Buddy1. I'll say that Buddy1 is barking. It will display as Buddy1 is barking. So how we can actually create multiple objects and just call these methods at an ease. In the next episode, we will explore much more nuances in these classes and objects, since this is just a basic vanilla OOPS, which is I'm just giving a flavor for your understanding. Once again, and then yes, I think we are done with this episode. And once again, I am extremely sorry for this delay. I've been stuck up with my personal things, so that's the reason for this delay. I hope I'll stick to my schedule from now, as everything seems to be all right, and I'm of course well motivated right now. See you soon. Stay tuned. If you like it, please do like, subscribe, and please put your valuable comments, such that if I forget everything, these comments will certainly motivate me to upload more videos at this point of time. Thanks a lot.